Hello and welcome to another free code session. My name is Jason Bach and I'm giving up on this. This whole idea of trying to make the range have a base type either as an interface with default interface members, or it is a type like this that has a protected constructor, and then how do I create it? And furthermore, this whole issue I've run into with the equality operators, and then you get this weird error, not weird, but this error with CA2260, which is not a compiler error, it's a code analysis error. I actually posted something to Discord, and folks from Microsoft explained kind of the rationale and reason behind this. Even if I was able to get this to work, then, I have this thing where I have to have a way to create ranges of the specific subtype, and then I'd have to have a method that implementers or inheritors would implement. It ends up becoming just a big, huge mess that really isn't helpful. If I thought maybe last night going back to doing it as an interface with default interface members would be the way to go. But then I forgot that if you have a variable that you want to call a member on it that is a dim, you actually have to cast it to that specific type, because that way you're able to call that method on the base type because it's actually not on the implementing type. So I said, screw it. We're going to go back to what it was. And what I'm going to do is this issue I've had out here, I'm actually going to use it and hijack it to say, let's put equality operators and parsable on the struct type for range. We're going to keep that switch in there for partition. Not ideal, but given everything else that I've been trying to do, I think it's the right thing to do. So give me a second. I'm actually going to close out this issue, and then I'm going to make a branch, and then I'm going to start working on this thing. So give me a minute. Okay, we're back to having this being a read-only struct. And so now we're going to do the equality operators, and then we're also going to do parsable. The first one should be easier. We're going to do that first. Parsable won't be hard. It's just the way I'm going to parse it is the format that comes out of toString. So I'm expecting, where is toString? There, so that you actually have a brace at the beginning, a parentheses at the end, there's a comma, and you take the start and the end on each side, and that's what you parse it to. Now, this will be interesting because T should have, you can't call, can you? Possibly. T dot. Can you do parse? Yes, you can. Yeah, that's actually perfect. I was like, can you do that? I'm like, I think you can. And that's actually going to work really well, because then we can parse each side for the T that is given. So, okay, let's do this. So we want equality operators of T, T, and bool. Right? Oh, range, I'm sorry. Range of T. I'm still kind of amazed that here in this interface, so it's already implemented. We've already done it. So that's why I said this was going to be an easy one. But it's interesting to note that here, that the equality operator, the result, if I go to it, I don't think it's constrained to anything. Yeah, it's just T self. So these equality operators, you could have them return an int. You could have them return an enumeration. You could have them return something else, which is kind of interesting. I haven't quite figured out in my head why they did that, but whatever, it works. Okay, let me go through this just real quick. I want to do an eyeball and all this stuff and make sure everything is good, and I think it is. Yeah, this is just nasty ugly, but whatever works. Okay, I think we're good. So now let's do parsable of range of T. And now let's implement that. And where did you implement it? Way down here, because of reasons. I'm going to pull that up here. Okay, we'll do that here. And what we're going to want to do is say, sorry, it's early. I'm still waking up thinking about how I want to do this. So I'm thinking parse should call try parse. And if it doesn't work, is there like a parse exception? Well, there's a regex parse exception, but that's not what I'm quite looking for. Do not declare static members on generic types. Well, what choice do I have? I mean, I guess, yeah, fine, but you're just going to have to shut up about that. That is a good point, though. Now that I think about this, maybe, but I kind of have to. I mean, I get why this is coming up here. Let me try to do this dance. This is one thing I do not like about these code analysis things that come from Microsoft, which is if it's something that is a violation or one to suppress the warnings, do not suppress a warning from this rule. If it's this bad, why not have this be a compiler error? I don't understand. If you really think it's this bad, then why would you? I mean, maybe it came in later, and this is trying to get people to do the quote unquote right thing. In the case of what I'm doing, though, I'm going to have to say range of int parse, and then I'm giving it a string that says parse it this way. Is there I'm kind of curious. I read only. There's a text parser. I was kind of wondering if they had something like it's interesting that when I do it this way, there's no span parsable. That's what I'm looking for. Yeah. We would probably want that too. And then we implement that and we get yelled at for doing this. And then we come back up here and put them here. And then we can debate this more. Because in this case, what I think I would do is I would just say range of t parse s as s span provider. Okay, so you would automatically go to the versions of this that. So let's do that. Let's say range of t try parse, which we're going to say s as span provider. Oh, result. Yep, that's what I want. And then what happens if s is see, that's okay, yeah, that's an extension. Okay. I was like, why isn't that not barking? Because if it's null, we return it. Okay. I can buy that. That makes sense. Okay. So we got this in place. I get what this is doing. I get what this is saying is that you don't want static members on generic types. I've run into this before. I totally understand why. But if you give me a string that has 3,7 in it, did you mean a byte? Did you mean a int? Did you mean a long? Did you mean a big integer? I have no idea. But you need to tell me what type it is. So I'm thinking in this case, we're going to do that. And we're going to do that. Okay. And actually, we're going to pull these out because they go down here. And then they can yell at me for this and that. And right now this makes sense to me, but maybe I come back to this and go, eh. But again, I just get annoyed with these things that saying, do not suppress this. You should not do this at all. And in this case, I'm kind of sitting there going, yeah. It kind of makes sense to me. You know, again, I understand why this is here. I totally understand why. But yeah, I'm okay with this. I'm all right. I'm okay. I'm okay. All right. So let's actually do this, because this is the one that basically everybody is going to be calling at the end of the day. Excuse me. That's right. Nice that I put it right next to toString, because then I can see what the value should be. So if s at 0 equals that, okay, and s at hat, is that it? Because if I say x length minus 1, it's going to tell me what you want to do is the index operator. Yeah, it's 1. I always get that wrong. Is equal to that. We want to get into this. So if we don't, we're going to say return false. Okay. And it's funny when we say maybe no one, because range is a struct. That can't happen. In fact, I should be able to take that off, right? Because it can't be null. Though taking that off just said, even the corresponding type disallows it. Huh, that's an interesting one. But in any event, okay. So what we want to do is take the span minus the beginning and the end, and then split it, okay? So parts, we're going to want to say s from 1 to hat 2, okay, split. You can't, because there's no okay, that's fine. That should give us if parts.index of any. Then we want to say var comma equal to parts index of, and we want to say that. Now, see, okay, this is where all the exceptional cases are coming through my head. What happens if you use this in a culture where the way that you format the number actually puts a comma in it? How would you be able to tell? Well, okay, so maybe that's where the space saves us, because what we want to do is actually say that. That's the index of what we want, okay? So, and we want to call this the delimiter. I think that would save us for if delimiter is greater than 0. And it should actually be greater than 0, because you should have something at the front, okay? So now we want to take var start is equal to parts of 0 up to the delimiter. Okay. And then the end is the start of the delimiter plus 1. Is that it? Dot dot. And just take the rest of it. If I do, sorry, I have to do this. If I do like 33 comma 66 this, okay. So what you're going to do is this becomes the parts. The delimiter is going to say you're here. So the start's going to say from 0 to 0, 1, and then the delimiter is going to start at 2, but that's exclusive. So we grab that. So we want to start at 2, 3, 4. We actually want to start at 4. So we want to do that, okay? Right, because it's That would be 0, 1, 2, 3. Yeah, 0, 1, 2, 3, 4. Watch Jason count. So 4, and then anything after the end of this. And so if we say var start, if, here's the fun part. If t dot try parse of start provider out to start value and t dot try parse end provider out end. Oh, that's right. I got to put a var there. Sorry. Out var out var end value. If that's all true, then result is equal to a new range of t start value end value. And if that fails because you gave us a range that had the numbers back, that's your problem. You did it wrong. Return true. There is something that comes across as very elegant about this. Why would you return false? Oh, so even if you didn't do that, so we could say here, result is equal to default. There. And then let's take these off because there is no null with a static, or not static, a struct. Wow. That actually feels, I mean, I know this code here is a little inelegant, but there's something about that makes me feel very happy. You know, and it handles the null here. We do provider right. We get the comma in the right spot. And now there's a lot to test here, actually. It ends up becoming, but the fact that you can do this try parse on the T and there's something that's giving me warm happiness right now. Okay. Now here what we want to do is say, how do we want to do this? I'm sorry, that's right here. I want to do that. Okay. And then this is going to be, I got to put that back there. This is what we're going to say. If range of t dot try parse of s provider out var result. Oh my God. Return result. Else. Now, what do we want to do here? We wanted to format exception. Maybe throw new format exception. And then we could do this. The given value s is not in the correct format. I kind of like this. And I don't like this because I'm feeling too good about myself that I wrote this. This is probably all the wrong. Okay. So what have we done? We added inequality operator, which we've already done. We just made it interfaced. We've added iparsable onto this and ispan parsable onto this as well. This is feeling much better than the last 2 episodes I've done. It feels a lot better. A lot better. Okay. So now let's go into here and go into our range tests and let's do some parsing. Okay. We're going to do some parsing. How do I want to do this? If I want to do sorry, I was thinking for a second, could I do this as a parameterized test? But I don't think that's going to quite work here. We're going to say here test public try parse. So we're going to have var content is equal to something like 3, 7. Okay. And then we want to say range of int. Ooh, could I do this? Assert multiple. Okay. No, you stop. Yeah. So we're going to say assert that. Assert true. Range of int try parse of our content of our range. That would be true, right? What are you barking at here? Oh, fine. Okay. That's fine. Is true. Now we should be able to say assert that range.start is, I thought that would be smarter than what it is. Okay, so format provider, we want to say culture info, whatever that is, current culture. Oh, look at that. That actually did. See, some of these features that came in C# later makes this really elegant, I think. I think it makes it so elegant. Now we can say 7 here and say that that's the end. Okay, let's run this. Oh, now you're coming back with this crap? I thought this had gone away. I know in a previous episode I talked about this where I was like, because next is a virtual. Yeah, and so I thought the reason they weren't doing that anymore is because that. I'm kind of wondering. So we have a pseudo random number generator, but then I thought there was a random number generator dot fill. But these are all statics, right? So if I said like get int 32 here, that's a static because this is an abstract class that doesn't have like an interface to say get. There's no way to inherit from this to say, I want to have a, if I come back down here, it's just a total static. So this is a little crappy because I'm just going to ignore this because I personally don't feel like this is because we don't know if it's insecure or not. Well, in fact, the way we do secure random is not. So we're just going to ignore that. In all honesty, the reason I did secure random in the first place was that there wasn't an easy way to do get int. So one thing that's coming out of this is maybe what I should do is consider making secure random obsolete, because though this get big integer with range is actually kind of nice. Maybe I could do that as an extension method on, rethink all this. Get big integer on a random number generator, even though you're not supposed to do extension methods on types you don't own. Get double values, get int 32 values. That's something to consider, is to make secure random obsolete. And then on the extensions here, actually, so I'll remember that for the next episode. Well, let's come back here to my range tests. Yes, again, maybe my logic is wrong. So let's go into range here. And let's look at this. Okay, are we in? Yes, we are. So let's see where this is failing. Okay, so that's good. Let's get our parts. So we should have, well, Yeah, that wouldn't be right. That's right. We want to disclude that. I just made up a new word. So let's see what that does now. And it passes. Cool. I'm not going to go through and writing all the rest of the test. That's an exercise for the interesting. Let's just make sure I didn't break anything else in here. Cool. Let's commit this, because I could have things that are still wrong with the parsing. So I need to handle those cases. But this is a very nice way to end this episode, especially the frustrations I've had with the last two. And I think this is ending up being as best of a right approach as possible with how I'm doing inheritance, not inheritance, default interface members, and all that junk. So I'll finish out the tests here, and then I'm also going to put in an issue to say, consider making the random, the secure random obsolete, and add extension methods to random number generator. So thank you all for watching. Leave comments and questions below. See you in the next episode.